Hi folks, Astronomy Live here, back from vacation. And I know I have a lot to get caught up on, and so we're going to start off tonight talking about the bright object seen in the southwest after sunset. Here's a recent video from the Biru Planet channel, and we're going to find out what this object really is.
Now, the picture on your screen that I want you to pay close attention to is an out-of-focus star. And this is not what we are seeing in the southwest region of the sky. The photograph on your screen now is a star. The photographs that are about to go across your screen are photographs that were taken by one of our loyal subscribers. His name is Doug, and Doug has captured the best photographs of this object that I have seen so far. Now, we've been getting emails from people all over the world sending in photographs and video. However, Doug's photographs are by far the best that I have seen. And ladies and gentlemen, we are not dealing with a star. We're not dealing with a meteor or an asteroid. This is clearly a planet, and it is coming from the southwest region of our skies. I would once again like to ask everyone who subscribes to this channel or watches our videos, please photograph or videotape this planet in the southwest region of the sky. You will see it clearly. It is not Venus. It is not any of the stars in our sky.
Okay, let's stop it there. First of all, the pictures of the out-of-focus star that he shows at the beginning of the video, these were taken with a catadioptric telescope, a telescope that has a secondary mirror in the front held in place by a glass plate, and this creates the donut shape that you see when the star is out of focus. Obviously, that is not the case here, later in the video, but that does not mean that it is not out of focus. Indeed, this is what an out-of-focus star or planet will look like if you're not using a catadioptric, but are instead using just a straight refractor with a lens. Here's an example in footage that can be found on WTF Sky's channel. This was footage that I actually recorded and sent to her, and she's put it on her YouTube channel. This was done a little bit facetiously, but it gets the point across that out-of-focus stars do look strange to some people, and they do look exactly like what you're seeing in this picture here. Okay, now let me skip forward a little bit on this video. Notice what happens as I focus this star. There we go. So, a couple things to notice here. First of all, obviously, it gets a lot smaller. It starts to look a lot more like the in-focus pictures that he showed at the beginning of the video. And, you can also notice a change in color as well. This will depend on which side of the focus the star is on. If it's on one side of the focus, it can look one color. Notice here it's kind of got this green hue to it. And right here, I've gone to the other side of focus, and notice it has more of an orange hue. And you can also see purple fringing around it as well. This is common with achromats, like the achromat I was using. They are not fully color corrected, and so when you're imaging stars with a CCD camera, you will pick up, in some cases, pretty severe color fringing. And so this is quite normal, but this is just what it looks like when you have the object out of focus. Now, as to whether or not the object is Venus or a known planet, for that we need to figure out what the coordinates are and see if it matches any known objects. The coordinates aren't given in this video, and we really don't have any points of reference here. But if we take a picture of that bright object in the southwest sky, as I did a few days ago, you can use a standard SLR camera and a tripod and take a long exposure and pick up all these beautiful stars surrounding the object in question. So notice all these other dots in the image. These are stars. This picture has actually been dark frame subtracted to remove the hot pixels, and you can see there is a bright object in the center of the frame. And if you upload that to astrometry.net, you can get an astrometrically solved picture and then download the new-image.fits file, which has the WCS data embedded in it in order to determine the precise coordinates of any given pixel in the image. Also, if you check out the original image and you go here to the full size, you can actually right-click on this, copy the image address, and pull this into any EXIF viewer, and you will have the EXIF data. And you can see here it was taken on November 25th. The time here is 8:43 p.m. Keep in mind this is 4 hours back from Universal Time, so it was 12:43:06 Universal Time on November 26th. So we can use that information to figure out whether or not this corresponds to the position of Venus. But the question is, where are we going to turn for coordinates for Venus? Well, you could use any given program. You could use Starry Night. You could even go to NASA and get the coordinates directly from NASA using JPL's Horizons system if you want very high accurate coordinates. But of course, that will beg the question, what if they're lying? I hear it all the time. How do you know that someone hasn't altered the software to make it appear that it's Venus when in all reality it's something else? So you can do the math yourself, and the orbital elements for Venus, along with the equations for its perturbations necessary to calculate its position precisely, have been published for decades. And I did a video on this last year, actually, and created a spreadsheet using equations that are found in the book Astronomical Formulae for Calculators. And this book actually uses Simon Newcomb's theory from the 19th century. These equations were actually originally published in the late 19th century and are over 100 years old, and yet they still work to an accuracy better than what you can see by eye. And so I've used this spreadsheet to calculate where Venus should have been at 12:43 Universal Time on November 26th at the location I was at. And you can see the right ascension and declination J2000 coordinates down here. Now, if we plug these coordinates into the astrometrically solved image, we find out that it matches the position of this bright object perfectly. This is the predicted position of Venus using Newcomb's equations from the 19th century, and it matches the image perfectly. And this image has a resolution of 16.7 arcseconds per pixel. And as I discussed in my previous video, 20/20 vision is the ability to resolve objects that are 1 arc minute apart, or 60 arcseconds. And so this image has about 4 times the resolving power as someone with 20/20 vision. And yet, even at that resolution, it still shows that it really is Venus, and it matches the predicted position of Venus perfectly. So that bright object in the southwest, that is indeed Venus. Thanks for watching. Clear your skies, folks.